Thank you for having me here. This is a collaborative research project, exploratory research project between the Indonesia Institute of Sciences and my home institution, the University of Buffalo. Rajiv and Tony are members of this team and several graduate students. And so what we want to do is an exploratory research project in GeoAI, specifically for the majority world, resource-constrained conditions. What is AI going to do, expensive AI going to do when you apply it to topics in emerging economies? And we have a study site in Indonesia, in Bali in particular, beautiful island of Bali that some of you might know. So we've been looking at Bali for 2 or 3 years now. I'm working with satellite data specifically from Planet Labs, and I'll get to the justification for that in an open source conference in a moment. But what we started to do was first look at what kind of land cover conditions can we actually detect with this new asset. For those of you who are not familiar with Planet Lab imagery, it is high resolution imagery at a very high temporal frequency. You get a fresh image every day, and that's meaningful in the tropics because of the cloud cover. Right? So if you work with Sentinel-2 data, where you have a revisit frequency of at best 5 days, and you have clouds 80% of the time, chances of getting a useful image is very small. So this is a new opportunity amongst other reasons for that particular feature. And so our first project was, as it says here, looking for tropical forest categories in the highlands of Bali, and this has simply not been done before. So Indonesia has mapped the archipelago, 11,000 islands, quite well with existing GIS methodology, but they haven't used high-resolution remote sensing to the degree that you could, to the degree that we do in Europe and in North America. So what happens when we apply these techniques to emerging economies, and when we then put this into the context of AI classification systems? And so in particular, to contextualize the reason for the study site, this is the Alas Mertajati. It is a area that is home to the Tamblingan, an indigenous group that has been arguing for land use rights of this area with the Indonesian government for a long time. And that process is ongoing, and part of the work that I'm doing is collaborating with a local NGO, VISNU, to find ways how we can document land use, historic land use practices based on land cover analysis. And so this is meaningful because of the way the Tamblingan have been using the land. They have techniques of sustainable agriculture that are becoming very prominent now because they're resistant to change in climate. They've been adapting to low rainfall or high rainfall conditions in interesting ways, and I'll show you that land condition in just a moment. And so here is how the VISNU Foundation, which is a local NGO that works with indigenous groups to map areas and define problems, environmental problems, most of them in response to land disputes, oftentimes fueled by the tourism industry. And so VISNU is our local partner. So my team is kind of like the science part, and we work with VISNU to interface with all the complicated Indonesian rules of how things have to happen. And then we work with the Tamblingan directly, who we confer with for pieces of information just to understand what their concerns are. And another part here that I'm trying to integrate in this project is to think about GeoAI as a project that is nascent, right? And do we have the opportunity to think about how large-scale machine learning is going to happen differently if we bring it into different contexts? And so it's slow in that regard, and it's purposely slow because I want to take the time to see what happens, as I'll show you in a moment, when you look at different constituencies and different stakeholder interests as you go through the machine learning process. And so what I built kind of like haphazardly, and just because I didn't have other tools that seemed to do everything I wanted, was a little framework. It's called Cocktail, that integrates headless QGIS, Orfeo machine learning library, GDAL, pCloud, all in a Python environment, just for collaboration. And so it's a machine learning environment that we can train classifiers, and we can work remotely. So I have someone in Indonesia working, and in the US working, and then they travel, and we can compare results. So one of the things that's important when you do machine learning is you have to, how did you set your parameters, for example? Like I want to replicate your results, right? You have like 20 parameters, right? So we kind of like share those parameter settings in a way that we can replicate results. We work with multiple forms of satellite data, so we can ingest Sentinel data or Planet Lab data. And then importantly, we take the products we produce outside of the machine learning framework. So it can be quite expensive to maintain a machine learning training environment. I mean, literally expensive, because like these are high-end machines. So if you produce lots of data, you want to move it out. You will be billed for it otherwise. And so to have a feature that just moves things out seems trivial, but makes a big difference if cost is an issue. And if you're working in emerging economies and in education context, cost is really important. Okay, so the first survey we did with the first generation of Planet Labs data, which was 4 bands, RGB and infrared, allowed us to differentiate forest cover quite well. Right? As I was saying, this is not perfect, but it was better than anything that I had done before. Our goal, however, was to look at these sustainable land use practices, and we were not able to do that with the 4-band data. What we wanted to do was map agroforestry. So agroforestry is important because it is a sustainable form of land use that is robust to climate fluctuations, as I mentioned, and has been used by the tumbling gun for generations. And so it's an interesting category to capture, but it's very difficult because it's very varied. And so I'm showing you here just three types, the topology of agroforestry that I found. And they basically vary by intensity of structure. If you just go by the vegetation, it's very hard to say what the difference is. But if you go according to a metric of intensity of how the land is used, some of them are hardly managed, and others very strongly managed, almost like a garden. You can kind of like get some grasp on it. And so last year, 2022, Planet Labs came up with a new constellation of satellites that had 4 additional bands. So we have a configuration that maps every point on the planet every 24 hours, offers 8 bands, specific bands that are useful for vegetation, and has a spatial resolution of below 4 meters. Bingo. We're able to use this, and it's just like, it just popped up. We're able to use this, and we're able to get instances of agroforestry. Now, so this is this asset that the Planet Lab came up with last year. So this is really new, and I was lucky to have access to that. And so we could go back to this agroforestry topic that we were struggling with. So the project was just going to, end with, due to inability to actually capture one of the most interesting features of the landscape and one of the politically charged features. Do you want me to do something? We're good? Okay. And so I'll just show you here like some comparison. Sentinel-2 versus Dove, that was the 4-band version of the satellite Planet Lab data, and then Super Dove. And you see it in the paper better. It's really bad projection here. But the spatial resolution is such that we can capture larger plots, right? So it's like bingo, we can get started here. And from the spectral resolution, you see kind of like we're starting to get spreads here in some of the bands, meaning we have enough information such that a machine learning system can latch on to something, right? This is about, do you have a signature in your information that a machine learning system, a statistical organizing machine, right, can latch onto? And so we find that. And so we can go from the existing categories that we have over to agroforestry, right? So there's a technical hook into this. So I'm going to just show you again what this agroforestry business looks like. Give you an idea. So agroforestry is really, think of it as a three-dimensional garden. Flower, coffee, and banana agroforestry. Okay, so lots of dogs. So it's a three-dimensional garden. So you have, at the top you have clove trees, then you have coffee plants, and then you have taro or fruits, no, it's fine, or albacea flowers, and this all grows together, and depending when one of them flowers or blooms, you get that fruit or this fruit is constantly going. Everything is always growing. It's not like a growing season, just always growing, always harvest something. And agroforestry is robust. It works with the climate, it works with the knowledge of the people, and has been in place for generations. So this works. Okay. Okay, so now this is kind of like the boring technical part. We had to make so many versions of our data collection. So I had people go out into the field to collect data with videos, send it back, and we evaluate, what is this? Is that a garden? Is that agroforestry? What? And then I went down myself for 2 weeks to kind of like augment that data set after we had arguments. What is this? It turned out, like version 13, we start to get something where we can, with some reasonable results, get agroforestry at the same time the mixed forests and at the same time the rice paddies. So we were able to optimize any one of those categories, but we had a hard time doing all three of them, right? And so there we go. That's our kind of like result. And it's not good. It's not perfect from a machine learning perspective, but it's the first time that's been done. It's 62% accuracy, F1 score rather, for agroforestry, for a category that has not been mapped in Indonesia before. So, and this is with support vector machines. So I'm going to show you the results that we have. So this is the first map of the Alas Mertajati with libSVM and 13 land cover categories. Little things here, quite interesting. These lines here, for example, that is actually a high voltage line covered in the forest, in a protected forest. There's a whole story behind that. And so one of the things we found, this was actually difficult to distinguish. If we used a low-dimensional neural network, and get to the differences later on, like it actually misclassified that human intervention as agroforestry, right? And so one of the topics that we were looking at, which is the best classifier, right? So when you think about the best classifier, you think about, okay, which one has the highest F1 scores, which performs best on a confusion matrix. And so we wanted to see also what type of contingencies do these classifiers require? Like, so for example, which one can we use with the lowest amount of data? Because data is hard to get, right? And neural nets are notorious for requiring massive amounts of data. So if we can use a classifier that works almost as well with much less data, that is an interesting candidate for resource-constrained environments. On top of that, the neural net just didn't quite get its act together, if you so want, with settlements. So it tended to overestimate the density of settlements. So for those two reasons, and because it's too expensive in terms of data collection, we moved away from shallow neural nets and continued to look at random forest and support vector machines. Now, so that's kind of like where the topic when it stops. We have a first land cover map of the Alas Mertajati. Bingo, good, right? Okay, great, hasn't been done. Now what I want to talk about are the types of errors that we encountered and how these errors are interesting opportunities to think about how we want to make machine learning happen, right? Because we can tweak these systems. And so one of the places where we started to look at the error categories was around this lake. This is Lake Tamlingan. It's a sacred lake to the Tamlingan, and there can be no economic activities in this lake, right? They are in the process of arguing with the Indonesian government of how to manage that. There are tourists who come here, they leave a mess. The Tamlingan are very concerned about this. And they want to make sure that when they represent the land, that this is a sacred site. So if I give them a fancy AI land cover classification that shows rice paddies, I've got a problem. I've got a problem with my AI. There's all kinds of slippages. But this is a particular type of problem because it's problematic for the stakeholders who are supposed to profit from this mapping operation. So with the SVM approach, we can simply take a few extra data points around the lake, run the classifier again, and this particular type of error disappears. So we purposely unbalance the data, which you're not supposed to do in machine learning. We purposely unbalance it to address one particular type of error that we favor over other types of error because of who the map is supposed to serve. And I think that's, while the whole details don't necessarily matter, this notion of that we want to take these machine learning systems that otherwise would just run off and do whatever they want, we want to take control over them. And taking control over these systems requires intervention in different places. Then I want to show you some of the problems we have with getting ground truth. So this is an area, unfortunately, in the fog, but it actually has the vegetation of agroforestry, but it's inside of a hotel complex, right? So it has the look of agroforestry, but it doesn't have the use. Now, the bad thing is that algorithms are blind to that, right? So the algorithm, even the best one, is going to classify this as agroforestry. So what kind of additional meta information do we have to add to address this? This is an open question. Likewise, here, a rice paddy that has now been abandoned and is going to be a construction site. This is in January. So there's all kinds of like transitional areas that that the classifier, in its attempt to be very strict about what is what, makes calls on that actually don't coincide with the realities on the ground. Moreover, you have the rice paddies, of course, the famous rice paddies of Bali that people go to see and see the pastoral landscape and how the farmers work the land. And a lot of times for farmers, it's no longer economically viable to produce rice. It's actually better to work in the service industry. So sometimes rich landowners will pay farmers to maintain the rice paddies, not for food production, but for the tourists. For the tourists just to look at. So here's another misuse of land use, if you want, that AI will never capture unless we find out how we can add additional pieces of information. Okay. So back to my kind of like product, if you want. We presented this to the Tamlingan, and they loved it. It's great, this never happened. But they had a hard time seeing all the details, right, in this mix. So so we make a product, this AI-produced system, and if you're in the field, you can read this, but if you're not, you actually have a harder time. And one of the problems was they couldn't distinguish, is this a photograph because of the color mappings, or is this a map, or what? It got confusing. So what we then tried to do was come up with ways, this is much better in the paper to look at, is how we could separate out some of the categories and put them in a neutral background, meaning in an infrared band of the particular image, such that one feature at a time would pop out. And so here's the settlements of I think it's 2020. Here, now the agroforestry of 2022. And when we did that, we were in a different position to communicate the results. And we could start to talk about, wait a minute, this area here, is it really that dense? We talk about it, we go back out in the field and check. So this was the hook that allowed us to make our information, our results, more meaningful to the stakeholders. And that's an interesting result. And then finally, I want to spend just 1 minute, if I have that, to talk about bad maps in emerging economies. So bad maps. So this is a hydrology map produced by the Indonesian government the year 2000. And it's the standard map. They did all of Bali. in that year. It's the standard map that people use to this day to demonstrate the water richness of the island. But the problem is Bali is running out of water. This map is a fiction. It doesn't represent the reality anymore. And I know this because I spoke with a tumbling gun and says, like, what is the water situation? It says it's bad. And so what we did is we spent the day just going out into the field and looking at some of the sites where there's supposed to be running water. This is during the rain season. And they were dry. And this was just a spot check. Out of, I want to say, 15 sites, 20% were dry, right? And so what I want to end with is this idea of the bad map, of the map that's an official map by a government in an emerging economy where you don't have the means to just update this right away, and it persists and becomes a framework that limits the opportunity to respond to these changes that are happening, the lack of water, that way differently when you don't have the resources to change it quickly. And so what we're doing now is, with the tumbling gun, with the use of the tumbling gun, we're doing a kind of like group action to go and find as many of these sources that we can. Take a video in the rain season and in the dry season, send it up, and we can make a new little map. And then here's the other part of the project. Government? No. Okay. Thank you very much for your time.